The project is called the Evaporative Cooling Partitions Project. We are developing prototypes of this partition system composed of columns which are filled with sand and water, and the idea behind them is that they cool through evaporation. We all are familiar with the headlines that we've seen record heat, and heat is not only a question of discomfort, it's also a question of life and death. Air conditioning is often used as a means of making us comfortable and managing heat, but it also consumes a lot of energy. So we're exploring kind of ancient technologies and seeing if these passive, energy-free technologies could have relevance today.
We gain valuable insights from this project by learning from the past and employ new technology and sustainable technology like 3D clay printing. 3D clay printing offers various advantages in terms of speed, efficiency, design flexibility, and thermal resistance, and it also saves costs and resources.
We are using computational tools, which is quite helpful in creating 3D models and to analyze the model, and also to creating texture on top of the surface of the models, because as you increase the surface area, you'll get more chance of evaporative cooling in the geometry.
Having this technology come back, it's kind of enchanting, because it's like using something people developed thousands of years ago, but putting it now to basically lower CO2 emissions.
We've always had a series of students involved, both at the graduate and undergraduate level. It gives them the opportunity to be engaged in research, in fundamental research questions that are happening at the university and in other areas, and to be very hands-on and to be involved in the narrative where this research goes.